Title, Ahmed, go.
Simple compound.
And can you all calculate interest now?
Yes.
Yes. And do you have a better understanding of what interest is and how to calculate it?
Yes.
You don't? Did you want to redo the lesson then?
I did do it.
Did you want to redo it with me then?
No.
Okay, do you have a better idea or not?
I do not.
Okay, then don't say no if I ask the question and it's not true. Okay? All right, your vocab, interest, you need to know what it is. I think you guys were pretty good on that word. Principal, I think you were pretty good on that word. Simple interest and compound interest, pretty self-explanatory based on the definitions. The key part to this lesson gets down to number 2 main idea. You need to know the formulas for simple interest and for compound interest. I know number 6 looks like a maze of arrows and so on, because it is a maze of arrows and so on, but you got to know what each of those letters represent. These are not my made-up formulas. These are real formulas. If you hit the Google, they'll tell you exactly the same thing. Okay? So make sure you are aware about all the different parts of a simple interest loan, pretty simple, and a compound interest loan, not as simple. A key to the compound interest loan, as you learn, is do you know how to run your calculator? If you know how to run your calculator, you understand order of operations, you will be pretty good on these problems, because after that it's really just plugging in numbers. Here you have an example of Megan buying a $20,000 car. We saw that the simple interest loan that she took out was at 5% over 3 years. In total, it's going to cost her $3,000 in interest, $23,000 total. What we did, just to show you a comparison, is we reduced the loan to 6 months to show you that if we only take out a 6-month loan at 5%, or if Megan only took out a 6-month loan at 5%, she would go from a $3,000 interest payment in total to a $500 interest payment in total. Moral of the story, the shorter amount of time you can take out a loan, the better you're going to be, right? Moving on. And then we did if she put a down payment. So if she decreased her loan amount from $20,000 to $14,000, still at 5%, still at 3 years, she saved herself $900 because now she's done a 22-1 instead of 23. Okay. One that's more intriguing is Chris in the house that he bought, $500,000 house. He put $100,000 down, plugged in our numbers for the formula at 5%, compounding monthly for 30 years. In total, Chris will pay almost $2 million for his $500,000 house. He's at $1,887,000 and some dollars for his house. If he has a 5% interest loan over the course of 30 years, that compounds monthly dominant. Then what we did, just for kicks and giggles, is we adjusted the loan so it compounded daily. So instead of compounding once a month, it compounded once a day. Changed our denominator in the fraction, changed one of our numbers in our exponent, and we saw that it cost, what did we say, an extra $6,000 bucks? About $5,000 more over 30 years. Not much, right? And then what we did, just for even more fun, is we, I don't think we have the data up here, do we? No. If you calculate this loan, and you'll remember this because you did it, if you calculate this loan compounding hourly, over the course of 30 years, could somebody tell us how much we increased from $1,892,000? Again, we went from compounding daily, 365 days a year, to compounding hourly. And our payment, or our total cost went up by how many dollars, Peyton? Was it 200? It was a little less than 200, right?
Yeah, a little about.
So the crazy fact, or the crazy stat, is that compounding from daily down to hourly, really over 30 years at this amount of money, didn't make a whole lot of difference. So we're talking about less than $200 on a $400,000 loan. That's pretty small, right? Bottom line is you need to know how to plug in numbers and work your calculator. Any questions?